Hello, this is Geometry, Notes 4.1, Classifying Triangles with Mrs. Moslick. We can classify triangles by its angles or by their sides. This is all review from previous math classes you should have had back in middle school. Let's look at the Chapter 4 vocabulary sheet to review these vocabulary words. So let's first of all look at classification of triangles by angles. You have an acute triangle if all angles are acute, meaning less than 90 degrees. You have a right triangle if one angle has a measure of 90 degrees. You have an obtuse triangle if you have one angle that is obtuse or has a measure more than 90 degrees. And finally, equiangular means all angles have the same measure. So each one would be 60 degrees. These are the classification of triangles by their angles. So equiangular, obtuse, right, and acute. If we look on the back side of this sheet of paper, we see that you can also classify triangles by their sides. Let's start with equilateral. Equilateral is when all sides have the same length. Isosceles, two sides have the same length. So the third one would be different. Scalene, all three sides have different lengths. So you represent the sides with different tick marks. So I'm just representing that in each of these triangles, the side lengths are different. Okay, so scalene, three sides are different. Isosceles, two sides are congruent, and equilateral, three sides are congruent. Let's use those vocabulary words to solve problems using algebra. So find the measures of the sides of an isosceles triangle. So an isosceles triangle, two sides are the same. They tell us that the base is KL. That means the other two sides are the legs, which are the congruent sides. So we'll set them equal to each other. 4D minus 13 equals 12 minus D. We'll use algebra to solve. Add D to both sides. And at the same time, add 13. So we have 5D equals 25. Divide both sides by 5. So D is 5. KM's length is 4D minus 13. So 4 times 5 minus 13 is 20 minus 13 is 7. And LM is 12 minus D. So 12 minus 5 is also 7. That's good to just double check that those are the same length. And then KL is D plus 6, which is 5 plus 6, which is 11. So we're done with the first example. Let's try the next example. So number 2 says, find x and the length of each side of this is equilateral. Well, since this is equilateral, all sides are the same length. So you can take any two of the sides and set them equal to each other. It does not matter which two sides you choose. Let's just choose 6x plus 1 and 3x plus 10. But you can choose any two of these three sides. Subtract 3x, you'll still get the same answer because it's equilateral. All three sides have the same length. Divide both sides by 3, so x turns out to be 3. So the length of line segment FH is 6x plus 1. So 6 times 3 is 18. 18 plus 1 is 19. Now, we know that because this is equilateral, the other two sides are also 19. On an assessment, I would highly encourage you to double check. So FG's length is 3x plus 10. Double check that we solved this correctly. So 9 plus 10 is indeed 19. And then finally, the length of line segment HG is 9x minus 8, or 9 times 3 minus 8. 27 minus 8 is also 19. So it's nice to check your work. Now, that's just some simple algebra problems. If you know the vocabulary words, those are pretty easy. Now, let's look on the back side and let's review distance formula. Example 3 says find the measures of the sides of triangle KPL and classify the triangle by its sides. So I am not going to draw a beautiful picture, just a quick picture of K would be -2, -6. So K is roughly here, P is roughly at -4, 0, and L is roughly at 3, -1. So just drawing the picture, it looks like it could be equilateral, it could be scalene, it could be isosceles. I'm not really sure by this poor drawing. So what we're going to do is we're going to classify the triangle by its side. So we have to find 3 distances. So since we have coordinate points, let's use the distance formula 3 times. So let's find the length of KP first of all. So K is -2, -6, and P is -4, 0. So we have our x1, y1, x2, y2. So we can write the distance formula once, but you do have to write it down once. It's the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared, and then plug in the particular numbers. So we have the distance between K and P is written as KP. You could also write it as the distance of line segment KP. That's a little messier, but both are correct notations. And then we have the square root of the quantity -4 minus a -2 squared plus 0 minus 6 squared. So we have the square root of -2 squared. It's important to keep those parentheses. So we have a negative times a negative is a positive. So we have 4 plus 36, which is the square root of 40. Now, we'll do a factor tree on 40. Let me just do it off to the side. I'll just use a different color. How about green on this? So we have 40 is two numbers that multiply to get 40. 4 and 10 for two numbers that multiply to get 4, 2 and 2, and both are prime numbers, so I'm going to circle them. And two numbers that multiply to get 10 are 2 and 5. And so those are also prime numbers, so I'm circling them. So we're going to rewrite this. So the square root of 40 is now the square root of 2 times 2 times 2 times 5. I always like to write the prime factorization from small numbers to big numbers, and then circle pairs of the same number. Go ahead and do that while my Microsoft Word comes back to life. And tell me what KP is. Once you have KP, go ahead and try another segment. How about PL? So we have, just to finish this off, we have 2, 2, 2, and 5. Circle a pair of 2's. Out comes that 2, and we're left with 2 times the square root of 10. So I'll write that down. So KP is 2 square root of 10. Let's find PL next, and I'll use a different color. How about purple? And so PL. So I'm going to rewrite what P is. So P is -4, 0. L is 3, -1. So we have x1, y1, x2, y2. And we will plug in the particular numbers into the quadratic formula. So the length of line segment PL is, or the distance of line segment PL is, both notations are fine. Just make sure you have the line segment here, no line segment over there for length of line segment. Square root of the quantity, 3 minus a -4 squared plus -1 minus 0 squared. And we have the square root of 3 plus 4 is 7 and -1 squared in parentheses. So we have 7 squared is 49 plus -1 squared is 1, square root of 50. Now the square root of 50 is 5 and 10. 5 is prime. 10 is 2 times 5. So we'll rewrite the square root of 50 and its prime factorization going from small to big numbers. Circle pairs of the same number. So out comes the 5. Inside stays the square root of 2. So PL's length is 5 square root of 2. 5 square root of 2. So we automatically know this is not equilateral. It could be isosceles or it could be scalene. So let's go ahead and now find the third segment's length. And so I'll just use red to use a different color. How about let's use find KL. So K's coordinate point is -2, -6. L is 3, -1. So the length of line segment KL is the same thing as the distance of line segment KL. Either notation is fine to write, but you have to write one of them. Label what you're finding. We have our x1, y1, x2, y2. So we have 3 minus a -2 squared plus -6 minus a -1 squared, which is the same thing as 5 squared plus -5 squared. So we have 25 plus 25, which is the same distance as what we had before, square root of 50, which we already calculated as 5 square root of 2. So we now know we have two sides that have the same measure. We'll go back to our picture and label that third side as 5 square root of 2. Therefore, two sides are the same. This is called, classify the triangle by its sides. It's us isosceles triangle. And we are done with that problem. Hope you enjoyed these notes. If you have questions, go back to these notes and then also feel free to ask me or your teacher.